Okay, so I'll start. Good morning, good evening, everyone. I am Shomadip from Indian Institute of Science. I'm taking this TA for the problem solving sessions for the course Numerical Methods for Engineers, which is being handled by Professor Niket Kaisare in the NPTEL platform. So this is the 6th week of class, and today we will be discussing about the different topics which are listed for this week, the 6th week. So first I'll give a quick recap of what I had discussed in the last class, and then I'll start over with the new topics. So if you have any questions or clarifications from the previous classes, you can ask me.
Hello.
Yes, Nasim.
I wanted to ask that in the multivariable Newton-Raphson method,
Yes.
suppose that we have some equation which is of three variables, then also we can apply that method.
Yes. Then your this okay. So this one you are asking, right? Multivariable Newton-Raphson. So if
Yes,
you
yes.
have
If
three
we
variables, you will
yes,
be
yes,
given with three equations, right? So
yes.
the thing will be the same, only your Jacobian matrix and all that will be of the order of 3 cross 3. So
Okay,
like it will here it is dou f by dou x, dou f by dou y, right? So one more column will be added, dou f by dou z. So here
yes, yes,
also this in the second column, one more thing, second row, one more element will be added, dou g by dou z. And you will be given with one more equation, right? So here there are two equations, f and g. So you'll have one more equation, h of x comma y comma z. So that will come in the third row. Then
okay,
you can
okay, okay,
apply the same method.
okay.
Anything else? Any other clarifications?
No, everything is clear till now.
Okay. So last class, what we had discussed, we'll quickly recap of what we had discussed in the last class. So basically, we were talking about nonlinear solving nonlinear equations, right? How to obtain the roots of different nonlinear equations. So in that respect, I had told that any equation or any system which you encountered in your real life, like your any field of study, if you think engineering or your science, physics, chemistry, biology, everywhere the equations won't be linear, and no two variables will have a linear relationship. So whatever we study in our linear equations as of that is for only for the that is only for studying purpose. Actually, in the practical case, you will have something different. You'll have nonlinear equations, right? So there, how to solve, how to get the roots of a particular nonlinear equation. So in that respect, last week we had discussed about two different schemes. One was the fixed point iteration scheme, and another was the Newton-Raphson method. So fixed point iteration scheme we discussed for single variable as well as multivariable. And Newton-Raphson method is one of the most popular numerical techniques for solving your nonlinear equations. And that also we discussed in details about the graphical interpretation, which is the most essential. Any numerical technique of solving any roots, whatever you study, you must understand the graphical interpretation of that. Otherwise, the essence of that method, the importance of that method, you will lose. You will not understand the importance of that method. Only if you just mark up the formula and you can pass your assignments. But to understand it and to apply it in a particular scenario, you will not be able to do unless you understand the graphical thing. So I stress on the graphical interpretation approach. You should study that again, and you should try to understand. Okay. So in fixed point iteration, which is also known as the successive substitution method. So what we do is any equation which is given to us, like f of x equal to 0 is given to us, right? So basically we rewrite that in the form of x equal to g of x. That is x equal to some function of x. This process of rewriting this equation is known as recasting. This process is known as recasting. So there can be, as we go on through this technique, we'll see that there are multiple processes, or there are many ways in which we can understand, in which we can recast our equation. That is, we rewrite our equation fx equal to 0 in the form of x equal to g of x. So then basically this f of x equal to 0, we are just rewriting it in the term of x equal to g of x, right? So what does this tell you? What is the root? F of x equal to 0. From this equation, as I had told you, what is the meaning of root? Graphically, if you see, f of x equal to 0. So basically, if you plot y equal to f of x graph and y equal to 0 graph, that is the x-axis. So basically, the intersection points will give you the roots, right? So we are just using an alternative technique of this fx equal to 0. We are rewriting it as x equal to g of x. So what we will do, we'll draw two curves, that y equal to g of x and y equal to x. Y equal to x is a straight line passing through the origin with a slope of 45 degree, as you know. With a slope of with an angle of inclination of 45 degree with the x-axis. So if you basically draw these two graphs, y equal to x and y equal to g of x, the intersection point of these two curves will give you the roots of the original equation, right? And this is an open bracket method or an open method. So it begins with an initial guess. That is, we need an initial guess of the root, which will be provided to you in the question. And for practical problems, based on the nature of the problem, you will have some initial solution to start with. So we basically using that initial solution or the initial guess of the root, we basically substitute that value in the g of x, and gradually we successively go on substituting these values. So we get different guesses of the roots x2, x3 like that until it converges. We can continue this process. So this is the basic method, and based on that I had solved some numericals. And I had discussed that the convergence of this method, that is the convergence of this fixed point iteration method, basically depends on two factors. One is the choice of gx, that is the choice of the recasting function, and your initial guess of the solution. So yeah, I had shown that if the initial guess of the solution is not correct, or then it can lead to diverging roots. So your roots will diverge from a particular point, and you will not get the correct roots of the equation. So this is the graphical approach. You can go through the lecture I've uploaded in YouTube. I'll send the link in the group also. Through NPTEL, you can access these lectures, the notes and the recordings. So this, and then we had discussed about the Newton-Raphson method. So it is basically an open method again to solve the function fx equal to 0. So what we do is, suppose this green line here is the curve, right? Is the y equal to fx, y equal to y equal to gx curve, and this blue line, it is y equal to x curve. So basically the points where it intersects gives us the roots. So I have shown here how, based on the initial guess of the solution, you can we are approaching towards the root. Suppose let us assume here that this a, that is a point on this x-axis marked in red, that is the initial guess to the solution. So what we do here, based on the initial guess, one second, sorry, this is the fixed point thing. So here is the Newton-Raphson thing, right? So Newton-Raphson, what we do, we have an initial guess which is given by A here. And based on A, we draw a vertical line from this point, from point of initial solution, and find the functional value at that point, which is given by f of x, f of x0. Suppose x0 is the initial guess of the solution, then the functional value is obviously f of x0, right? So based on that, we draw a tangent at this point, and we extend the tangent to meet the x-axis. So the x-intercept rather of this tangent gives you the next iterative solution. That is, A is x0, and here we have B, which is given by x of 1. Again, we follow the same procedure. We draw a vertical line, find the functional value, draw a tangent, and this x-intercept of the tangent will be your next solution. So like this, we are gradually moving towards the root, right? So this is the graphical interpretation of this Newton-Raphson method. And based on the equation of this tangent, you can derive the iterative formula for Newton-Raphson method for single variable, which is given by this x of I plus 1 is equal to xi, that is x of I plus 1 means the value at the current step, right, is given by the value at the previous step minus this fx by f dash x. So how we got this formula, you can check the derivation. And based on this, we had solved one equation, and then we solved one application problem based on van der Waals equation on fixed point method. And then we moved on to multivariable Newton-Raphson method, right? So in multivariable Newton-Raphson method, we basically, instead of this f dash x, we basically use a matrix here, which is called the Jacobian matrix. So this Jacobian matrix is nothing but it is a matrix of the partial derivatives of the two functions with respect to the two variables x and y. And based on this equation, we find the Jacobian matrix, and then finally we get the solution. So here this process is very hectic, and hence we in your exam you will not be given more than one or maximum two steps. Two steps will not be given. Maximum it will be one step. They'll ask the value of the solution after the first step. And this type of methods, we can write a MATLAB code for that, and then we can obviously solve this type of equations. So one class I can take on the MATLAB coding. Once I complete this course, I can take one session on this MATLAB, how to code this in MATLAB, and that will obviously help you in your understanding of the methods more easily. Will that be fine for both of you?
Yes, yes, sure. That will be helpful.
Yes, sir.
Okay. Once I've complete this course, then one more session I'll take at the last. So that will basically deal with the MATLAB coding part. Okay, so this was all which I had discussed in the last class. So today we will be studying a new topic. So we'll be talking about regression today. So anyone of you, do you have an idea of what regression is, or you have come across this term previously in mathematics or anywhere?
Heard of this term regression, but don't know how to means what is it.
Okay. Okay, fine. No issues. Archana, have you heard of this term regression? And do you know what is the meaning of that?
No, sir. No, sir.
Okay. Okay, Archana, can you tell me from which background you are, like BTech or
Sir, BCA, sir.
BCA? You are in the final year.
Yes, sir.
Okay, fine. So regression basically means to find a relation, or like when we draw a graph, when we plot a curve, basically, suppose you are given some y equal to f of x curve and some random curve I am drawing here. Say some this kind of curve you are given. So suppose this is y equal to f of x. So here there are two variables, right? One is y, one is x. So one of them is the dependent variable and another is the independent variable. So can you tell me which one is the dependent variable and which one is the independent variable?
X is independent
Y
variable
is
and Y is variable.
Yes, Nasim, please tell me.
Y is the dependent.
Yeah,
Y
y
is the
is the
dependent.
dependent variable and x is the independent variable, right? So
Yes,
this
yes.
you have to be clear. Dependent variable and x is your okay. So suppose this is a general example, right? So I'll give you a more specific example. Suppose you have okay. Suppose in your Nasim, you are from chemistry background, right?
Yes, yes.
Okay. Suppose you have conducted some experiments, and based on the experiments, you have obtained the volume of a solution. Any mixture you can tell. So the volume of that solution you have obtained over time. I'm just giving a random example. Okay. So you have obtained, you have at different times, or rather, not this example. Suppose you are driving a car, okay, and at different instants of time, you have a stopwatch with you, and you measure the velocity of the car from the speedometer over different instants of time. Say you start the experiment at say 10 o'clock in the morning, and at that time your velocity was say 80 kilometers per hour. So 10 o'clock I'm taking as a reference. So that is t equal to 0. Suppose you measure it after 20 minutes again, and your speed is 120 kilometers per hour. Again, after 20 minutes you measure, and your speed is say 100 kilometers per hour. So can you tell me which is the dependent and which is the independent variable here between velocity and time?
The velocity is the dependent variable.
Yes, correct. So your velocity is the dependent variable. Why is it the dependent variable? Because your time is not dependent on the velocity. You are measuring the velocity, right? So your velocity is dependent on your time. So basically this is the independent variable and this is the dependent variable, right? Okay. So suppose you take this measurement for different instants of time, right? So after another 60 minutes, suppose you see your speed is 70 kilometers per hour. Suppose after another 30 minutes, you observe your velocity to be 50 kilometers per hour. Another 30 minutes, you observe your speed to be 85 kilometers per hour. So you get some data, right? So what you can do is suppose you have this data with you, the set of X and Y. So always remember, while plotting, always your dependent variable will be on the Y axis and your independent variable will be on the X axis, right? So here you have 0 to 120, 0, 20, 40, 60, 80, 120. So this is 20, 40. Just I'm trying to tell you what regression is through this example. Okay. And your velocity is varying from lowest is 50. Okay. So here is 20, 40, 60, 80. 100, 120. Okay. So this is your velocity in kilometers per hour and this is your time in minutes. So now if you want to plot this data, so at 0 it is 80, right? So it is this point. Then at 20 minutes it is 120 kilometers per hour. So approximately here. At 40 minutes it is 100 kilometers per hour. At 60 minutes it is around 70 kilometers per hour, right? At 90 minutes it is 50 kilometers per hour. 120 minutes it is again 85 kilometers per hour. 1 second, I'll just change it. So I will change 90. This is 120. Okay, I've just changed the values. I'll just plot it again. So it is 120. This is 90. This is I'm saying 30 kilometers per hour. Is it clear what I'm doing?
Yes, yes.
Okay. So I'm just plotting this data. So at 20 it is around 90. At 40 it is around 100, right? At 60 it is around 70 kilometers per hour. At 90 it is around 50 kilometers per hour. And at 120, 1 second, 60 it is. I'll draw it exactly, otherwise it will be difficult. If you do 120, 20, it's 90, 40, it is 100. At 60, it is 70 kilometers per hour. At 90, it is 50. So suppose these are your points, right? So these are your points. So basically, you can see all these points will not, if you try to join these points and form a curve, you are seeing that it is not getting in the same straight line, right? So if I want to draw a straight line somehow to connect these points, what I can do? So there can be multiple straight lines, right? Suppose one straight line I draw like this. Like this I can draw. Another straight line I can draw. Like this I can draw. Another straight line I can draw. So there are three different straight lines, right? So you can see, right? You can understand. There are three different straight lines which I can draw here. Multiple other straight lines are possible. So now you can understand. So can you tell me which is the most accurate line which represents all the data? Suppose this left one I'm telling line 1, middle one is line 2, and this one is line 3. So can you tell me which line most accurately represents the plot?
The line 2, because it is closest to the maximum number of points.
Yes, correct. Archana, is it clear to you?
Yes, sir.
So which line is the most accurate?
That second line, sir.
Why is it most accurate? Do you think?
It it covered the every point.
Yeah, it's not covering all the points. This point it is not covering, right? But still it is
Yeah.
covering most of the points, and it is closest to all the points, right? So this is the basic aim of regression. So basically this is what is regression. Suppose you have from an experiment you have a set of data, right? And from that data you want to predict, or you want to find a line, find a straight line in linear regression which is closest to your expected value, which is closest to your experimental value. That is what is known as regression. Is the idea of regression clear to you, or should I repeat it again?
No, sir, it's clear.
It's clear, right? So now,
Yes, sir.
okay. So one more example I'll give you here. This is X, this is Y. Suppose you have like this some point. Suppose you have like this, okay? You have obtained your X and Y data from any experiment, suppose, and then you want to get the line of best fit. That is the line. What is line of best fit? So basically a line of best fit means the line which is closest to your experimental values. Okay. So suppose I draw a line like this. Suppose I draw a line like this. This is one line is possible. Another line is possible. Suppose you have a value here also. 0 at 0. Okay. So like this, multiple lines are possible, right? If I draw one from here, this is also possible. If I draw one from here, that is also possible. So based on this, you have to find which is the most accurate, line. Okay. So that is known as regression. So this is why you might ask why we are considering only a straight line. There can be different other curves also, right? So for now, we are considering only linear regression. We'll also see about nonlinear regression today itself, and we'll see there how we deal with different other curves also, right? So I'll write the important points here. So what is meant by regression? It is nothing but prediction just a second. Prediction of the dependent variable, not only prediction, and proposing a relation between the dependent and independent variable. So this relation will be linear, that is a straight line. The general equation of straight line is y equal to mx plus c, right? For linear regression. Okay. So now, so here what I told, I'll write it. Multiple straight lines possible. Find the most accurate line. We have to find the most accurate line, right? So this is the main aim of our regression. So how can we find the most accurate line? So I'll do that. So we'll do it step by step. Okay. So in linear regression, so the first step is you have to either plot or tabulate the available experimental data. So you have conducted your experiment and then you plot or tabulate your available experimental data. Is it fine? Okay. So the next step will be draw a straight line along the plot, which has the equation y equal to a1x plus a0. So this is the general equation of that line. Okay. Now you might ask that which straight line I will draw. There are multiple straight lines possible, right? So now the question obviously arises, which straight line shall I draw? So for that, we have to follow the next step. So what is the third step? You have to calculate the error with respect to the line. So now to understand this, we'll go back to this plot. So here, as I asked you, which straight line is the closest or which is the most accurate line representing the plot, you directly answered that it is line 2. Based on what you answered, you told that it is passing through most of the points, or it is close to most of the experimental points, right? So this closeness, how is it determined? It is determined based on the error, right? So to find out any error, we need two quantities, right? One is experimental value and the other is the true value or the predicted value. One is the experimental value, other is the predicted value. So what is your predicted value? Suppose I'm telling you in this graph only, if you see, suppose at x equal to 40, what is your true value and what is your predicted value? Can you tell me? Can someone tell me what is the predicted, what is the true value? You first tell me at x equal to 40 from this graph or this table.
100 km/h, it is the true value.
Yeah, it is the true value that is you have obtained from experiments, right? So Archana, can you now tell me what is the rather the predicted value at x equal to 40? Archana, am I audible? Maybe she's not there. Archana, are you there? Okay, fine. So Nasim, can you tell me what is the predicted value here? Exact value you do, obviously you don't know whether it is less than or equal to the or greater than the actual true value. Can you tell me?
It can be anything like
No, based on this line 2, you tell me.
okay, line 2, based on line 2, it is between it's great, you can say greater than 85 and no,
Yeah,
greater,
means
not.
if this is the true value, is it
Yes,
less
yes,
than
yes.
or greater than the true value? That I'm asking.
It is less than the true value.
It is less than the true value, right?
Yes, yes.
So here is your predicted value. So this one is the error. The absolute difference, the difference between the true value and the predicted value. So similarly, you can also calculate for every point what is the error. So how will you calculate the error? So true value minus, or rather we'll write the other way around. It is predicted value minus true value. So if I just simplify it, what is the predicted value? It is yi, right? That is the equation of the line. Yi at xi. Sorry, the predict, 1 second. It's not this one, it's the other way around. True value minus. So your true value is given by from the experimental data yi minus your predicted value is based on the equation of the line, right? So it is basically a1 xi plus a naught. So this is your error. If I write here, this is my true value and this is my predicted value. So now for every step we can calculate this error, right? For every value of x, you have a true value and you have a predicted value. So for every point I equal to 1 to the total number of points, you can calculate this ei. So once you know EI, so in fourth step, what we will do is we will sum all these errors. Now this sum can be done in multiple ways. We'll see here. So the first possibility is total error will be given by summation of I equal to 1 to n all the errors, right? So if I write this I equal to 1 to n yi minus a1 xi plus n. So now the problem with summing all the errors is it will not give you the actual picture. Why? Because I'll show you. Suppose I have a plot like this. So suppose y and x values, right? We will draw the straight line first. Suppose your data points are like this. Say here it is like this. Suppose your data points are like this. So can you tell me at this point, I've zoomed in. So at this point of x, suppose this is x1. Say this is your x2. This is your x3. This is your x4. This is x5. This is x7. And this is x6. These are the 7 different sample points you have. And you have the predicted, the red points, it shows the true values, and the green line, the violet or the purple line, it shows you the predicted values, right? So can you tell me at x1, if I calculate the error like this, the true value minus the predicted value, at x1, the error is positive or negative? Can you tell me just by looking at the graph? Archana? Okay, she is not there. Nasim, can you tell me at x1, is the error positive or negative?
I think it is 0.
At x1, not the first point, not the origin point, the next point I'm talking about.
I think it's
X1.
positive.
Okay, so why do you think it is positive? Archana, can you clarify? Yes.
It's to,
Can you tell me why is it positive you are thinking?
it's towards the y-axis, positive y-axis.
Yes. Can you come once again?
It's towards the positive y-axis, so I think it is positive.
Oh, did you understand the concept what I'm talking about? Hello? Did you
Yes,
understand the
sir.
concept what I'm talking about?
Yes, sir.
So what are these red points representing here that I have marked? Can you tell, or if you don't know, you can tell me. I'll describe again. If you don't understand at any point, you can tell me.
Okay, sir.
What are the red points? Do you know, or shall I tell?
Yes, sir. You explain once again, sir.
So these red points here are my experimental values, right? Or the true values. And the corresponding violet line, whatever I have drawn here, these are my predicted values, right?
Yes, sir.
So at x1, you have one red point and one green point, right? So your green point is the predicted value and the red point is the true value. So now if I calculate the error like this, that is true value minus predicted value, can you tell me at x1 the error will be positive or negative?
It's negative, negative.
It is negative, right? No, it is not negative. It is true value minus predicted value. So true value is greater than the predicted value here, right? So it is positive. The true value is red minus the green value is the predicted value. So error is positive at x1.
Can you zoom the where is x1 lying? The point?
You are able to see? I have zoomed it.
Okay, okay, okay. Understood, understood.
Yeah.
It is greater, greater. So error will be positive.
Yeah. At x2, can you tell me, Archana, whether the error is positive or negative?
It's positive only, sir.
Yeah. So at x3,
3 is negative.
yeah, because the true value is less than the predicted value, right?
It is less than value.
Yes.
True value is less than the predicted value in x3, so it is negative.
Yeah. So like that, you can tell x4 again it is positive. X5 again it is negative here x5 and x6 again it is positive. Okay. So now you have some set of positive and negative values, right? So if you calculate the error like this, just you sum up all the errors, you might end up getting 0 as the error, total error. Suppose you have 3 positive numbers and 3 negative numbers. So if you add them up, it might happen that the total error sums up to be 0. But that is not the actual picture what we are trying to describe here, because that is not the best fit line. So basically I'm trying to tell that suppose there are like this +1, +2, +3 for x1, x2, x3. And for one second, +1, +2, -3. For x4 it is positive. So it is, I'm telling it is, say it is +4. X5 again it is negative, right? So it is -5 I am telling. And for x6 it is again positive. Don't consider x7 here. X6 it is positive, right? So it is 3, 4, 7, 8. So for x6 you consider the error is +1. So these are the different errors, suppose the difference between the predicted and the true values. So this is for x1, this is for x2, this is x3, x4, x5, x6. So if I just sum up this all these xi's, that is the ei's, so what you will get, just if you sum up 6 plus 1 7 minus 7 plus 1 8 minus 8, it is 0. So it is telling you that the error is 0. So what does that mean? So that basically conveys a meaning that it is passing through all the points. So total error, if you are telling us 0, it means that your line is passing through all the points, but that is not the case. So just summing up of these errors like this will not give you the exact picture of the error. Is this concept clear?
Yes, it is clear.
Okay. Archana, is it clear?
Yes, sir.
Okay. So like this, if we just modify this error, the description of this error and do it like this, E is given by summation of if we sum up the squares of this number, then it will give me the exact thing. Y1 yi minus a1 xi. So if I square this and then sum up, so that will not give me any negative number, because square of any positive or negative number will always be positive. So that will give me an idea of the actual error. So that's why whenever we describe error here, we express the error as the sum of the difference between the predicted and the true value, and we do not sum up them, rather we square the errors and then sum up. Is it clear?
Yes, it is clear.
Okay. So now, so what is our goal here? We have found out the error, right? So our goal was to find the best fit line, right? So what do you mean by finding the line? So obviously it means finding the equation of the line, right? To find the equation of the line. So what is the equation of the line? It is basically y equal to a1x plus a0. So finding the equation of the line means basically we have to find these two coefficients, a1 and a0. So what should be the condition? The condition is you have to find y equal to, you have to find a0 and a1 such that the error is minimized. What was my error? Is basically yi minus a1xi plus a0 whole square, right? So basically, if you want to minimize this function and find out a1 and a0, so what should we do? So you have learned about maxima and minima in calculus in class 11, 12, right? So to minimize a
Yes, yes.
function, what is the condition?
Double derivative should be greater than 0.
That is the next condition. What is the first condition for maxima or minima? What is the first condition?
Means we have to equate it to 0 and find the
What we have to equate? What we have to equate to 0?
we have to first derivate it and equate it to 0 and find the solutions. And
No, one second, can you can you tell?
we have to differentiate it and equate it to 0. Then we have to find the solutions, solving the
Correct.
equation.
So here, based on this equation, we have to find a1 and a0, right? Yi and xi is known to us. So with what respect to which variables should we differentiate here?
A1 only.
First, we have to differentiate with respect to a1, partial derivative with respect to a1, equate it to 0. Also, we have to differentiate with respect to a0 and then equate to 0. So can you tell me, just for asking whether you have understood this thing, why is it that at the maximum and minimum points of a function, the derivative is equal to 0? Means, can you explain that? What actually happens?
Sorry, can you repeat your question, please?
So my question is, suppose you have a function, right? Just consider a general function f of x. So we tell that at the point of maxima and minima of that function, the derivative of that function we equate it to 0, right? So why I'm asking that, why do we do that? What is the graphical interpretation of that? Yes, are you able to hear me properly?
Yes, yes, I can hear.
Yeah, can you do you know?
So I forgot it. Can't remember.
Okay, okay, fine, no problem. Archana, are you do you know that?
No, sir.
Okay, fine. So suppose we have any function, right? Suppose you have a function like this. Suppose a random function I'm telling. 1 second. Right. So here, like this. So suppose here is which is the maximum point here? This is the maximum point, right? So at any point, if we calculate the slope of this function, what does the slope represent? It is basically at that point, you draw a tangent to the curve, right? If you draw a tangent like this, so that is the slope of this line. So at the point of maxima, or suppose you have the minima here, suppose you have a curve like this, and this is your point of minima, right? So see, if we draw a tangent at the point of maxima and minima, always it will be a straight line which is parallel to the x-axis, right? Here you can see it is a line parallel to the x-axis. So what is the slope of a line parallel to x-axis? Archana, can you tell? Yes, Archana, can you tell what is the slope of a line parallel to x-axis?
It is equal to 1, sir.
Slope of a line parallel to x-axis is equal to 1. Yes, are you sure? Hello?
Yes, sir.
Nasim, what is the slope of a line parallel to x-axis?
It will be 0 because
Yeah.
angle is 0.
Yeah, the slope of a line parallel to x-axis is always 0. Right. So that's why, so at the point of maxima or the minima, since the slope of the tangent at that point is equal to 0, basically the slope represents the derivative, or the derivative represents the slope, right? So that's why we equate it to 0. So that idea should be clear. Now is it clear? Can I move forward?
Yes, it is clear. You can move.
Okay, fine. So this is so basically if we try to differentiate this function with respect to a1 and a not equal to 0. So this is a complex function. Summation is there. So if you do this derivation, you can find out. I'm not doing the derivation here. So any standard mathematics book you can refer and find out what is how to differentiate that, or you can yourself do that. So you can find out a1. So what is a1? A1 is summation xi summation yi minus n. So this is the formula for A1, and A0 is summation yi minus A1 summation. So if we differentiate and equate the error term to 0, we will get the values of A1 and A0 as this one. So what is the difference between summation xi? The first term in A0, A1, is summation xi multiplied by summation of yi. And the second term is there is one term summation xi yi. So these two terms are different, right? We'll see how is it different in the thing. So basically summation xi means you just add up all the values of x. Summation yi means the corresponding values of y you add up. Whereas summation xi yi means you find out xy, the product at each step, and then you sum the total thing. First you multiply and then you sum up. So that is summation xi yi. Is it clear?
Yes, it is clear.
Okay. So you have to remember these two formulas for the exam. Mostly these will be given to you, but still for safe side you can remember. So we'll see one problem first. The application of this formula, right? So suppose you have conducted some experiments and you have got the x and the y values. Suppose the x values are 5, 10, 15 and 20 and the corresponding y values are 10, 55, 92, 120. Okay, just I'll take 5 minutes break and come back. Can take a break and then come back. Okay.
Okay, sure.
Okay, so I'll start. You're here, right, Nasim and Archana?
Yes,
Yes, sir.
yes. You can continue.
Okay. Okay. So here, basically, you are given this table, this data you are given, right? X and Y data. From that, you have to find the best fit line. That is basically you have to find A1 and A0. So here, how will we proceed? So we know that in order to find A1 and A0, we need all these variable terms, right? Summation xi, yi, summation xi, yi. So basically, we will prepare a table first. X is there. Y is there. We'll calculate xy and we will calculate xi, yi. So this is basically xi, yi, xi square. 5, 10, 15, and 20. Yi is 10, 55, 92, 120. Xi, yi. Just you multiply x and y, right? So it is 50, 550. This is 1380, 240. Xi square, right? 25, 100, 225. So if you sum up this,
50.
yes,
Summation of xi 50.
summation of xi is 50. Summation of xi is 50. Summation of yi is 277. Summation xi yi is
438.
4380. And summation xi square is 7.
750.
So now just we have to substitute, right? What is A1? A1 is summation xi summation yi n summation xi yi by summation xi whole square minus n summation. So summation xi is 50 into 277 minus what is n? N is the number of data points, right? So it is 4.
4, 4.
XIYI is 4380 by 50 square minus 40. So if you calculate this, A1 will come around 7.34.
7.3400.
Yeah, just we are taking up to the second decimal place. So it is 7.34. Similarly, if you find out xi, a naught, sorry. So it is summation yi minus a1 summation xi by n. So summation
N.
yi is 277. A1 is 7.34 multiplied by xi, summation xi is 50 by. So this you will get around minus 22.5.
Minus 22.5.
Yes. So what is the equation now? Equation of the best fit line. So it is basically y equal to a1x plus a naught, right? So
Yes.
y is equal to 7.34x minus. So this is the equation of the best fit line of the data which is given to you. Is this process clear to you?
Yes, sir.
Yes, yes, it is clear.
Archana, is it clear?
Yes, sir. Yes, sir.
Okay, fine. So now we will move to a new topic based on regression only. So we'll see now how to linearize a non-linear data. How to linearize a non-linear data. So suppose you have a data which you cannot fit in the form of a straight line. Suppose it is in the form of, you can fit it in some non-linear form. Suppose first one is the exponential form, right? So how to convert that data to linear form? Suppose we have an equation y equal to a e to the power bx. So if you basically plot this, so this is your y equal to a e to the power bx, where this is a, right? So how will you linearize this? Any idea on how to get us the same equation? Just if you change these y and x variables, how will you get a linear form of this function? Means you have to express this y equal to a e to the power bx in the form of y equal to mx plus c. Any idea on how we can do that?
We can use the series of exponential x, like Taylor series expansion.
That
Not
is there, but there is an approximation, right? And that is uh, computationally it is expensive also. Any other, just by just if I apply, if you take logarithm on both sides, means suppose ln I am taking on both sides, so it will be ln y equal to ln a e to the power bx. So how can you write the left hand side?
ln a
Plus
plus
bx,
bx
right?
plus bx, yes.
Ln e is 1. So now if I change my y to y dash, and y dash is this value, and x is same, this is my x, this is my a naught, a1, sorry, a naught, and this is my a1. So if I rewrite this equation like this, so isn't this a linear form? Just if I transform this y to y dash, which is ln of y, I'm getting a linear form of this equation. Is it clear to you?
Yes, yes, clear.
Archana, is it clear?
Yes, sir. Yes, sir.
Okay, fine. So we are getting a linear form from this. Similarly, if we have another, say, you have a power equation like this, ax to the power b. If I apply ln to this, it will be ln a plus b ln x. So similarly, if I make this as y dashed, this as x dash, this as a naught, and this as a1, we will get a linear form, right? Just you have to change the variables. That's it. You have to change these variables. Okay. So one more I'll show here. Suppose you have this kind of equation. So here, if I just do this, ax plus b by x, 1 by y will be equal to a plus 1 by x into b, right? So if I change this to y dash, this to a naught, this to a1, and this to x dash. So this will be another linear equation. Just y dash will be 1 by y and x dash will be 1 by x. Is this concept clear, or should I explain it once again? Because this is very important.
Yes, yes, the concept is clear.
Clear, right? Okay. So We'll see a problem how to handle this kind of problem. Okay. Archana, is the concept clear?
Yes, sir.
So this is also called as functional regression. That was linear regression. This is functional regression. So suppose you are given a thing, you are given a data, some temperature time and some P pressure is given. So this is given, the functional form will be given to you. It is basically an exponential form. Okay. Y equal to a to the power bx. So this is not a linear thing. You cannot fit a linear graph to this data set, data point. So you'll have to fit some exponential curve. It is given to you. It will be given to you in the question. So y equal to a to the power bx means if we transform this, y dash will be a naught plus a1x. So y dash is basically ln y. So you will have a linear regression basically. So here y and x, they have a non-linear regression, right? Non-linear relation. Whereas your if y dash is equal to ln x, so y dash and x, y dash and x will have a linear relation, right? So basically from this, the question will asked will be to find a and b, right? So first you have to, any equation, any nonlinear equation, if it is given to you, you have to first express it in the linear form. Then only we can use the linear regression formula a0 and a1 values. So here my y dash is changed, right? It is given as ln x and x is same. So this is your x here. This is your y here, right? So now we have to first find out y dash, which is ln y. So I'll bring the calculator. So ln of 0.1 is minus 2.303. Ln of 0.5 is minus 0.693. Four zero five. Ln of 1.482. So now your y dash is now known to you, right? So now similar to linear regression. So now you forget this p or the y. You have to find a linear regression between this y dash and x. So you have to first find out xi square, yi dash square, xi, yi dash. So your new y is this ln y. So that you have to remember. So xi square, if I find out, xi square is, this is 1, this is 3.24. Is the thing clear to both of you? Or the concept is clear, right?
Yes, I understood.
Okay.
Yes, sir.
So xi yi dash, can you tell me? It is basically minus 2.303, 3.243, 5, 6. Sorry. This is xi into yi dash. So 1.8 to minus 0.693. That is 1.247. So yi dash, right? 2.6 into 0.405. It is 1.053. And this is 3.4 into 1. 5.039. Now we'll find out what is summation xi. Summation xi is 8.8. So summation xi square is, and summation yi dash will be, which is around minus 1.109. Summation xi square is 1 plus 3.24, 6.76, 22.56. Summation xi yi dash is basically 5.039, 1.05347. Now if I want to find out A1, A1 is basically summation xi, summation yi in summation xi yi by summation xi whole square minus n into summation xi square. So if you substitute this 8.8 into summation yi minus 1.109 minus n is basically 4, right? Psi yi 2.5 by 22.5, sorry, this is 8.8 whole square, 22.56. If I substitute this and calculate, I'll get A1 to be around 1.557 and A naught. A naught is basically, what is A naught? Is summation yi. So here not yi, it is all our yi dashed, right? So summation yi dash minus A1 summation xi by n. So it is basically minus 1.109 minus 4 into 8.8 by 4. If I calculate this, it will come around minus 3.703. So now this is the A1 and A naught, right? So what was my equation? This is not over yet. So my equation was y equal to a e to the power bx, and what we have obtained is y dash equal to a naught plus a1x, right? So how did we get this? It was ln plus it was bx, right? So this was y dash a naught plus a1x. So here I have to find out a and b from this equation, from the left hand side equation, right? So a naught is, if you just compare these two equations, a naught is ln a and a1 is equal to b. So your a is basically e to the power a naught and your b is basically a1. So a will be e to the power minus a naught is 3.703. So a will be around 0.0246 and b is given by a1, which is 1.57. Is this thing clear? This numerical is clear to you how to do when linear equation is not available, that is a functional regression. How to linearize a non-linear data and then how to proceed. Is it clear to you?
Yes, it is
Yes,
clear.
sir.
It's clear, right?
Yes, sir. After finding the log terms of y, we can forget the p term, and for further calculation, we have to use the log terms.
Yes.
Then the method is same before the regression method. Same
Yes,
method.
yes, correct.
Yes.
Okay, so this is done. So now, just a second. Okay, so last topic for today. So it is matrix approach to find the regression coefficients. So this regression coefficients, that is this A0 and A1, they have a very complex formula, right? So it is difficult to remember this type of formulas. So there is a much easier method. You have to remember less, but the calculation will be more. So basically, what you have to do is we'll represent these linear equations and the experimental values as some matrices, and we'll do some matrix operation to find out the regression coefficient, that is A0 and A1. So we'll see how we'll do that. So for this, first of all, so the experimental data are given to us, right? X1, Y1, X2, Y2, like this we have till Xn and Yn, right? So based on this, we have A0 plus. So these are the experimental data and these are the predicted values, right? Y3 dash. So like this, you will have the predicted values, that is from the regression line. So you will have like this. So if we try to represent this as a matrix form, how we will do that? So it is basically Y matrix. If we represent like this, Y dash rather, A naught. So like this, if we represent Y1 dashed, Y2 dash, Y3 dash, like this, we have till Yn dash. Okay. And X, if we represent in this form, 1, 1, dot, 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 1 till n rows. This one we have x1, x2 till xn. So now if we represent the matrices like this, y dash and x, so this set of equations, this y1 dash equal to a naught plus a1 x1, this we can represent like this. So you have another coefficient matrix which is a naught and a1, right? You have your, I'll write the matrices once more here, 1 dot 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 is x1, x2 dot 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 xn, and you have the y matrix which is y1 dashed, y2 dashed dot 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 to yn dash. So if I write like this, y dash, okay, so I'll derive it. If you multiply x and phi, what you will get? So can you tell me what we will get if we multiply x and phi? So first you tell me what is the matrix size of x? Means how means what is the size of x? So is this matrix multiplication possible? What is the condition for matrix multiplication?
Rows and
Number of
columns.
columns matrix is equal to number of rows in the second matrix.
Yeah. So what is the order of this X matrix? Can you tell me from here?
And n cross 2.
Yeah. So it is n
Yeah,
cross 2. N cross 2, right? What is the order of this phi matrix?
2 cross 1.
2 cross 1. So the rows and columns of this matrix are equal. So matrix multiplication is possible. What will be the order of the resultant matrix? Yes, Archana?
That is 2 cross
Now, how do you find out?
first row and first column. We have to multiply.
See, suppose I am not talking of the multiplication. Now you have two matrices which are n cross 2 and n cross 1. So the order of the
Yes, sir.
resultant matrix will be n cross 1, right?
One, yes, sir.
N cross 1. So now, what will be the first element in this matrix? If you multiply this,
A naught.
first element will be only a naught.
A naught plus A1 X1.
A naught
Yes.
plus A1 X1.
So second element will be a naught plus a1 x2. Like this, it will go a naught plus a1 xn, right? And this is my y dash, right? So from this, we can write y dash is equal to x5, right? So y dash is known to you, x is known to you. So you can find out phi, that is the coefficient matrix from here. But you have to remember one thing. So normally if we do it, we will get phi equal to x inverse y, right? But this is not correct because you cannot find the inverse of this n cross 2 matrix. To find an inverse, it has to be a square matrix, right? So this is not correct. Just remember this. From directly from here, you cannot find out this thing. So you have to do some matrix manipulation and then you have to find out, and you will see that this phi will be equal to x transpose x whole inverse multiplied by x transpose y. So this derivation is not necessary for you. At least if you remember this formula, then you can easily get the coefficient matrices. So we'll solve the same problem with this approach. So is it clear to you?
Yes,
Yes, sir.
understood.
Okay. So we'll do the same problem, right? So it was basically, I'll bring the problem again. The first problem which we did, x and y was given, right? Not the non-linear one. So it was 5, 10, 10, 20, 10, 55, 92, and 120. So now x and y is given to you. So from this, first we will find out what is X matrix. What is X? 1, 1, 1, 1. So there are 4 elements here. And here you have 5, 10, 15, 20. What is Y here? Y is basically 10, 55, 92, 120. So now you have to find out phi. What is phi? It is X transpose X whole inverse into X transpose Y, right? X transpose Y. So we'll first find out what is X transpose. So what is X transpose here? How to find the transpose of a matrix? Just the rows we have to convert into columns and columns into rows. So it will be 1, 1, 1, 1, 15, sorry, 5, 10, 15, 20, 5, 10, 15. So now if I multiply X transpose into X, basically 1, 1, 1, 5, 10. Can you tell me what will be the X transpose X if I multiply? Can you calculate this X transpose into X?
Yes, it will be 4 by 4 matrix.
Will it be 4 by 4 or 2 by 2? What is the order of X transpose? X
2 cross
transpose is? Yes, Archana?
4. X transpose is 2 cross 4.
Oh, sorry.
It is 4 cross 2.
1 second, I have done one mistake here. Just reverse I have written. This is X transpose. Okay, so 1, 1, 1, 1, 5, 10, 20. Here it will be 1, 1, 1, 1, 5, 10. So X transpose is basically 2 cross 4, right? And X is
This is 2
4,
cross
4
2.
cross 2.
Cross
So
2.
the
That is
resultant matrix will be
2. 2 cross
2
2
2.
cross
cross
2.
2. So can you tell me what will be the first element?
It will be 4.
4. Next, Archana, can you tell what is the next element?
Yes, sir.
So first row into first column we have done. Now first row into second column we have to do, right?
Yes. 50, sir.
50. So third element is also 50 and this is 7. Okay, this is X transpose X. Now one more term is remaining, which is X transpose Y. So X transpose into Y. What is X transpose? Basically 1, 1, 1, 1, 5, 10, 15, 20. Y is 10, 55, 92, 120. So this is 2 cross 4. This is 4 cross 1. So you'll get 2 cross 1, right? So if you calculate, this will be 277. This will be 438. It's 2 cross 1. So now X transpose X whole inverse into X transpose Y. From this, so X transpose X is how much? 450, 57, 50. That is 450 into 277,438. So if you calculate this inverse, it will be this I've calculated already. By taking the adjoint, you can calculate. Multiplied by 277,4380. So this, if you multiply, you will get minus 22.5 and 7. So this is your A0. This is your A1. So same values you are getting from the matrix approach. So this problem, when we solved using this this normal technique, we got this one, right? A0 is minus 22.5, A1 is 7.34. So when we calculated using this matrix approach, it is also the same. Is it clear to you?
Yes, it
Yes,
is
sir.
clear.
It's clear, right? Okay. Any doubts, anything you want to ask from the previous class or anything?
Can you check question number 7 of week 6 assignment? I can't means understand the language.
1 second, I'll check. Can you just take a photo and send it in the chat section here? I'll see. It will take time to open actually. Can you just take a photo and send in the chat section?
Yes, yes, I am sending.
Week 6, seventh question you are asking.
Yes, yes, question number 7.
So when is the last date for this week 6th assignment?
It is means next week Wednesday.
Okay. Okay, seventh question. This one, right? Recall that we fit the linear model like that, right?
Yes, yes.
Okay, I'll just see. So this question, it is telling that y and x is given to you, right? So in
Yes,
problem 1, they are telling your x is the independent variable and y is the dependent variable. With respect to that, you have to calculate all these things. But in the second problem, they're just reversing it. X is the dependent variable, y is the independent variable. Okay. And you
yes,
have to
yes.
fit a linear model x equal to b0 plus b1y. Okay. So just you have to interchange x and y here. In the formulas of a0 and a1, everything, you have to interchange x and y. So seventh question, they are telling recall that we fit the linear model to the same data. In problem 1, we want to compare the results of the values of b0 and b1. We can rearrange the linear, obtain the equivalent values of. This is a good question. You tell me what you have not understood. I cannot tell how to solve it. You tell me what you have not understood.
Mean basically what is the means it is saying I cannot understand.
So basically, two models they are asking you to fit, right? One
Yes,
is
but
the first model,
that
which is x is the dependent variable and y is the independent variable. And in
yes,
the
yes.
second, they are telling the reverse thing. So from both these models, from first model you will get a0 and a1. From second
Okay,
model you will get b0 and b1, right? So
okay,
basically
okay,
you have to derive a relation between this a0, a1 and b0 and b1. And
okay,
using that relation, once you find out b0, b1, you have to go back and calculate a0 from that value.
okay, okay. Means it will be two equation and we have to solve means rearrange and
Yes, yes, yes. Any other doubt?
no, this question only.
Archana, any other doubts from the assignments or anything you want to clarify?
No, sir, no, sir. I completed week 6.
Week 6 you have submitted.
Yes, sir, already submitted.
Okay.
Sir, finding the B1 and B0 is nothing but in the formula we have to interchange just x and y values.
Yes, yes, correct. You have to interchange x and y values. Because here,
Ah,
try to understand this thing. Here they're telling that first model, your x is independent, and y is dependent variable. So for that, we have derived whatever formula we have. So the formula which you have derived for a0 and a1, everything is with respect that the x is the independent variable. So if you interchange the independent and the dependent variable, obviously your formula will also change. Only the x and y values will interchange.
yes, sir. After finding the B1 and B0, again the A1 and A0 values will also change.
That you have to think. I'll not tell that.
Yes, yes, sir, yes, sir, it will change.
Okay.
Yes, sir.
Okay then. Actually, next 2 Saturdays you won't have any class. I'm going actually for a trip for a conference in Germany, so I'll not be available. We will again meet on 10th of September, which is a Tuesday. So see, this 31st August, this Saturday class, I have compensated today, 27th, and 7th September class, 7th September Saturday, that class will be compensated on 10th September. So next session you will have on 10th of September, Tuesday, 7 to 9 p.m. Okay. You'll get a mail
Okay,
for
okay,
that
sure.
also. You will get a mail for that also.
Okay, sir.
Okay then, fine. We'll meet on 10th evening.
Okay, sir. Thank you, sir.
Okay, thank
Yeah.
you.
Thank you. Bye.
Bye, sir.